Right now, you're sitting somewhere on a small rocky planet, inside one galaxy, inside a universe so vast it breaks human imagination. But here's the question almost nobody can actually answer. What is at the very edge of the universe? Does it even have one? To understand this, you first need to unlearn something. The universe isn't expanding into empty space. Space itself is stretching, everywhere, all at once. Imagine a balloon covered in dots, slowly inflating. Every dot moves away from every other dot. No dot is the center. That's our universe. So there's no edge you could fly toward and touch, like the edge of a table. But there is a boundary. It's just invisible. It's called the observable universe, and it's defined by something surprisingly simple: light. Specifically, how far light has had time to travel. The universe is about 13.8 billion years old, so you'd think we could only see 13.8 billion light years away. But that's not quite right. Because space has been stretching this entire time, the most distant light we see left its source 13.8 billion years ago, but that source is now even farther away. Today, the edge of our observable universe sits about 46.5 billion light-years from Earth, in every single direction, forming a sphere around us. That gives us an observable universe roughly 93 billion light-years across. And that's just what we can see, not what exists. Here's where it gets genuinely unsettling. Beyond that boundary, there could be more universe, possibly infinite amounts of it. We simply cannot know. Light from those regions hasn't had time to reach us yet, and because of cosmic expansion, it may never reach us at all. Some of those galaxies, right now, are moving away from us faster than light itself travels, simply because space between us is stretching that fast. So somewhere out there, galaxies exist that we will never see, never photograph, never receive a single signal from, ever, no matter how long we wait.
This isn't science fiction. Established physics allows this. Nothing is moving faster than light through space. Space itself is doing the moving.
This raises an enormous question that cosmologists still argue about today. Is the universe infinite, or simply unimaginably large but finite? If the universe is infinite, that changes everything. An infinite universe means infinite galaxies, infinite stars, and mathematically, infinite versions of everything that could possibly exist. Some physicists, working with the data from cosmic background radiation, believe the universe is flat, and a flat universe extending forever would indeed be infinite. But measurements aren't perfect. Other models suggest the universe could be slightly curved, like the surface of a sphere, finite but without any actual edge.
Picture an ant walking. It can walk forever in one direction and never hit a wall. Yet the surface is finite.
That's one leading idea. Our three-dimensional universe might be the surface of some higher dimensional shape, finite in size, but with absolutely no boundary anywhere. If that's true, traveling far enough in one direction wouldn't bring you to an edge. It would eventually bring you right back to where you started.
Then there's an even stranger possibility, one many physicists take seriously. Our entire observable universe might just be one tiny bubble inside something larger.
This idea is called the multiverse, and it suggests that what we call the universe may only be one region within an unimaginably larger structure. Under this theory, separate bubble universes could exist beyond ours, each with potentially different physical laws, different constants, even different numbers of dimensions. We have no direct evidence that multiverses exist, but the mathematics behind cosmic inflation, the rapid expansion right after the Big Bang, strongly hints at the possibility. So when you ask what's at the edge of the universe, the honest scientific answer is layered. There's an edge to what we can see, but maybe none to what exists. Our instruments, our telescopes, our entire civilization's understanding are boxed inside a sphere of light, 93 billion light, and that sphere is all we will ever directly know. Everything beyond it, infinite space, finite curved space, multiple universes, remains permanently locked behind a wall made not of matter, but of time itself. And that might be the strangest part of this entire question. The edge of the universe isn't really a place. It's a moment in time we can never outrun.
Let's go even deeper, because there's another layer to this mystery that most people never even consider. What existed before the universe began expanding at all?
There's one more layer. Asking what existed before the universe began might not even be a meaningful question, because time itself appears to have started at the Big Bang. Asking what happened before the Big Bang might be like asking what's north of the North Pole. The question assumes a direction that simply doesn't exist. A fraction of a second after the Big Bang, something called cosmic inflation caused the universe to expand so violently that everything was stretched apart almost instantly. In that fraction of a second, the universe ballooned by a factor of at least 10 to the 78th power, a number so large it cannot be meaningfully written out. Some physicists believe inflation never truly stopped everywhere. New bubble universes may constantly be forming right now in regions we will never be able to observe. Every tool we've ever built only detects light, and light has limits. The cosmic horizon isn't a technology problem, it's built into the universe's own physics forever. Tonight, when you look up at the stars, every photon hitting your eyes has been traveling for billions of years. You're looking directly into the deep past of the universe. The true edge of the universe, if one even exists, is something no human will likely ever see. And maybe that's not a tragedy. Maybe that's just the shape of existence. The true edge of the universe, if one even exists, is something no human will likely ever see. And maybe that's not a tragedy. Maybe that's just the shape of existence.